So the first thing I did is I went and, well, I read for a little bit. And then what I did after I read and satisfied my curiosity for some other problems, I remembered your problem. So I got in the shower, which is what I do when I want to solve a big problem. And I thought about your problem while I'm showering, and I'll try and lead you through the process of how I've thought of this as a way of solving the problem you have sent. So let's take a look. And I'll try and make this as short as possible, but I'm leading you through my thought process, which can sometimes be a little bit long. I'll do my best. So here's the deal. I know that we've got 10 generals. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. And they need a security system such that any 3 of them can determine the code to launch nuclear missiles, but no 2 of them can. All right, cool. It is possible to devise such a system by using a quadratic polynomial. That's a huge hint, and a great one, and a fun one. This is what really helped me out. To launch the missiles, one must compute A, B, and C. No problem. One cannot just tell each general one of A, B, or C, as then it is possible that some subset of 3 generals won't know A, B, and C. In other words, let's be specific. So here's the polynomial I used in the shower to think about. I generated one by thinking of 2x squared minus 5x plus 3, and I generated from the roots, so I know that it's an easy one for the generals to come up with, or someone to come up with anyway. And here's the deal. If our main number, if the numbers we're looking for, here's the code, right? We're looking for 2, -5, and it has to include negative integers, or this won't necessarily work. I mean, it can. If it doesn't include negative integers, you just can't use negative integers in your polynomial, and I decided to do so just to make it small, to keep the number small, basically. So if this is our function, if this is our polynomial function, we usually say f of x. Great, then these 3 numbers are the code they would need to arm the missiles. So in such an instance, then if I gave each one a number, -5, 3, I'd only have 3 numbers to give out. So I would have to repeat at some point. And you can probably see, I hope you can understand why this is a problem. Let me finish writing it, 3 and then 2. The problem here is that, let's say these 3 generals get together. Well, great, then they can arm the missiles. That's just fine. No 2 can obviously arm the missiles by themselves, whether it's 3 and 2 or -5 and 2. They can't do it. Worst case scenario is 2 and 2. They've got the same number that happens to be the same part of the code, so that's really useless. And the issue here is not that this is great so far. This is exactly more or less what we're looking for, except for one thing. That means too that if, let's say, this general and this general and this general over here get together, well, we've got a problem. They're going to be missing part of the code. They'll only have 2 of the right coefficients, and they won't have the full code available to them. So that won't work. Worse yet would be if these got together. I guess not. I guess it's the same problem. 2, or I guess really worse yet would be if 3 generals all with the same number got together. That would be a real problem. So this is a no-go situation here. This is a no-go. So we're going to, let's regenerate these generals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got to give them something that's going to work here. But the big hint here is quadratic. So we'll see in a moment how we can do this. If a general knows 2 of A, B, C, then a set of generals can launch the missiles. What information should be given to the general so that any 3 can find A, B, C, but no 2 can? Any 3 can find it, but never 2. That means we have to be able to, honestly, the easiest way I think to think about this problem is we need to find a way to give the generals, each of the generals, a unique key, a unique set of numbers or a number itself, so that when they get together, the 3 numbers combined gives them enough information to come up with this function. But if any 2 of them get together, they can't. And this is actually and we'll get to, that's the first part of the problem, right? This is the first part. We'll get to the second part in a little bit. All right, so that being the first part of the problem, what would happen? Okay, well, what are three things that work towards generating a function? You have two possibilities when it comes to such a thing. And let's make an example. We'll just do an example one. I'm just going to make this up for the moment because in reality this is not necessarily what it would look like. And in fact, it's definitely not what it's going to look like if we were to put this function out there. It doesn't matter right now though. Here's what any quadratic function looks like. It always looks like a U, either up or down. So let me think about this. What two pieces of information would not be enough to make this? Actually, the way that I can have not enough information, if I give points to the generals. If I give one general this point, let's say this is 5, 3, I'm just making that up, and let's say I give another general this point, and we'll say this is 3, negative 2, that's not enough information for me to come up with a curve, is it? I won't be able to come up with any curves to that, because I would need a third point to even determine that it's a curve. In other words, with only 2 points, really, the only thing I'd be able to figure out is a straight line. There's one line that can go through any 2 points, but there are an infinite number of curves I could possibly get out of those 2 points. I could get this kind of a curve, or I could get something that's a much longer curve. I could get all sorts of different curves to go through those 2 points. So 2 points isn't enough. However, if I had 3 points, it would be enough to figure out, and I'll actually show how we could get the function from the points. But that would be enough to do it. And the best part is I can do that. I can come up with a unique point on the same curve for every general. So that even if 3 generals get together, 2 of them, it's impossible for 2 of them to have the same point. Therefore, they won't ever be left out in the dark like these guys over here would be if I did it that way. Okay, there's one stipulation to this. I don't want to give more than one root. And I think we went over this vaguely a little bit, very little, in the last video that we just did, in your last problem. Here's the reason why. If I had the roots, and I happen to know ahead of time what the roots are to this because I generated it from the roots. So the roots to this are, and never mind y for now, but it's x is equal to, so when x is equal to, watch the last video if you want to remember how to get the roots to a function. It's not the easiest way to generate roots, but I haven't showed that before. For this one, it's, let's see, what was it? It was 2 times 3 is 6, but negative 2 times negative 3 is also 6. Negative 2 plus negative 3 will give negative 5. So it's 2 and 3. 2 and 3. All right, never mind how I got that, but this is how I first got this function in the first place. I chose just 2 random numbers that were small, and then I came up with this function over here. So this is what x is actually equal to. And so if I have those for the roots, so if that's the case, then really we're going to see something much more like, let me try and, I didn't need to delete everything, my goodness. I might have to cut this video into 2, by the way. Maybe not. Okay, let's see. Okay, so if I want, that's not enough room. All right, get rid of that. All right, so if the roots are 2 and 3, then I'm going to see 1, 2, I'll see 1 root here, and that's really not very much room. This is why you always have to prepare before lessons, but didn't do that today. 2 and 3, so I would have 1 here and 1 here. So this is enough not to draw a curve, but from the 2 roots alone, I could come up with a function. It wouldn't necessarily be the right function, but if somebody told me that the coefficients had to be integers, so we'll make this a big stipulation. If someone said that these coefficients, 2, negative 5, and 3, whatever they are, they'd be just a, b, and c, right? We don't know what it is yet. So in ax squared plus bx plus c, come on, c. Come on, c. There you go. That's supposed to be a plus sign. There we go. If a, b, and c are all integers, that means that we don't get fractions or anything like that, then I really could come up with just a single function from 2 roots. And I'm not going to show why right now, but let's just say that the important stipulation here is I don't want to give just 2 roots. What I would give the generals instead is something more like this. I would give them points. So in secret, if I'm the one designing the security system, in secret I'm doing this. I'm thinking, okay, I already know what the function is, I know what the coefficients are, but I don't want the generals to know until 3 of them get together. So let me come up with the points that I can give them that will serve as their keys in such a situation. So I'm going to use, I think I'm just going to use 1, and then I'm going to jump and do 3 and 5. Those are probably, I think those are the ones I did in the shower. It doesn't really matter. Okay, so let's see what, that's the x coordinate to those points. Let's find out what the y coordinate is by plugging those numbers in for x. So 1 squared is 1 times 2 is 2, minus 5 times 1, which is negative, so that's going to be negative 3, plus 3 is 0. So notice I've already given away one of the, that's funny. I must have gotten the roots wrong. Hold on a second. What are the roots to this function? Wait a minute. Hold on. 1x minus 3. Huh. Weird. Oh, when y is 0. Yeah. Crazy. Okay. I'll come back to that later to figure out what the heck is going on there. Maybe I didn't write down the function I actually generated this from. It doesn't matter, though. It doesn't matter. As long as I have the right quadratic, that's what matters. Okay. Then 3. If I plug in 3, I'll get 9 times 2 is 18. Negative 5 times 3 is 15, negative 15. So 18 minus 15 is 3, plus 3 is 6. All right, and then 5. 5 squared is 25, times 2 is 50. And then 5 and 5, that's going to be negative 25. So that'll be 0, plus 3 is 3. All right, I hope I did that right. Let me see. 25. Oh, no, 50 minus 25 is 25, plus 3 is 28. It's already gotten to be a big number. 28. All right, so this thing looks already, I'm really surprised about this. Hold on a second. Oh, I know why. I didn't generate it from those. These are not the roots. I did. I used other numbers, and then I completely forgot about them. Totally made that up. So never mind. Those are not the roots of the function. Regardless, were it for another polynomial, if you had the roots, you could figure out what the function was, if you had the right roots, of course. Those were not the right roots. One of the roots is clearly 1, 0. 1, 0. All right. But as long as I don't give away both roots and I don't stipulate the code to be integers, then we're good. We're still okay. So I don't know where the other root is. I could find it, but I don't want to right now. This is enough. I know what my function is. I don't really care what the graph looks like at this moment. I know what the function is. I have a table of values, and I can give every general a unique value in this way. But at a minimum, they need 3 points. So let's just say for now, I give this general 1, 0. I tell you, okay, it's a quadratic function. I'm giving each of you a different number, and you can only know each other's numbers when you get together. Right? So 3, 6, and then 5, 28. 5, 28. Now, let's assume that I give all the other generals a bunch of other values. I don't want to spend, in other words, the whole video coming up with a point right now for every general. But in theory, I could and should if I want the security system to work properly. They should all have a unique number, a unique point. But let's see how this is enough for just 3 generals to be able to do it. Now, for 2 generals, look, I only have 2 points, 3, 6, and then 5, 28 way up here. If those are my 2 points, is this pad of paper still working? I may have to pause and get it going again in a second. Hold on just a sec. Okay, I'm back. Hopefully this will speed things up a little bit. I had to delete some files from the temp folder. Okay, so 2 points. If I only have 2 points, assuming they're 3, 6, and 5, 28, I can make a line, but I'll have no way of understanding how to make a curve. Even if I'm not graphing it, there's no way I can take just those 2 points and figure it out. And I'll tell you why. It's because with 3 points, I can do it. So I'll show you how it's done with 3 points and why it won't work for 2 points. So let's say the 3 generals get together and they say, okay, we've got these 3 points. We need to generate the function. They don't know this function yet. They don't know what it is, but they need to generate it from these 3 points. They say, okay, I don't have a calculator. Do you? No. Okay, we have no calculator, so let's figure out how to solve this. So we know that it's going to be ax squared plus bx plus c. They have to be told that 3 points is enough to generate the function, and then it's going to be quadratic. Look at that, it's still slowing down. Well, I'm out of options, so I'll just keep trying. Okay, so they know it's quadratic. They have to know that in order for this to work. Then what they can do is they can each plug their point into the function, even though they don't know what the coefficients are yet. So let's call this general A, big B, and big C. General A plugs in his 2 points. Remember that this thing is equal to f of x or y. Let me put it on the other side. That's how you're normally going to see it in class. All right, come on. All right, so it's equal to f of x or y. So our x and y coordinates, right? So first general big A says, okay, I plug in 1, so I'll get a times 1 squared plus b times 1 plus c will be equal to my y value, which is 0. My y value, which is 0. Come on. Here we go. Okay, fantastic. All right, so that's working out. Once we calculate this, we'll see that this must be, so 1 squared is just 1. So this is going to be the same thing as saying a plus b times 1. Anything times 1 is just that number. So b, a plus b plus c equals 0 for general 1. For general big A. All right, so they have their equation ready. Then general B says, okay, well, I have a different point. I have 3, 6. So let me plug in 3 for x plus b times 3 plus c equals, and my y value will be 6. Any day now, will be 6. Yes, great. Okay, so if we want these all to well, let's just keep going. Let's keep going. We're doing great. So 3 squared is 9. So let's change this coefficient, this temporary coefficient. I'll not refer to it as a coefficient since that's confusing. We don't know what the coefficients to the actual function are yet. We're still trying to figure that out. But that is 9. So I'm going to say a times 3 squared is 9a. Cool. And then what is 3 times b? That's an easy one. That is just 3b. That is 3b. Oh my goodness, I may have to restart just to be able to get all of the video in. And then nothing times c. So this remains c and this remains 6. So 9a plus 3b plus c equals 6. And then let's get big C, general big C over here. Give me just a second. All right, I took a brief moment just to see if I could get this thing to go a little faster. Let's see if it worked. All right, so general big C will then have the point 5, so we'll do a, oh, that's so much better. A times, oh, it's already slowing down. Okay, nothing could be done. Times 5 squared plus, let's see, b times 5, not sure why I hesitated there, getting back into the flow a little bit, plus c equals our y coordinate 28. Yep, guess that's just how it's gonna be. Any day, 28, you got it. Okay, meaning that this is going to be 25a, 5 squared is 25. Probably just have skipped this part of it since I think you get the gist of how we are getting these numbers. 25a and 5b plus 5b plus c equals 28. All right. You didn't get rid of my b. There we go. Okay. All right. What did I say? 5b. All right. So there are a couple of things we can do. I am going to simplify this guy. So here's the deal. What we're looking at here is what's called a linear, not linear. I mean, it is currently. It's called a linear system of equations. So let me explain why it's linear here. It is linear. And the reason why it's linear is because linear system, come on, of equations. We call it this because what it means is, basically I go, look, I'm ignoring, I've got x's. X's are fine. Really what I have right now between these three, I have three equations which together make up a system. And from these three equations, I can figure out what the three missing values are, what the three variables are. If I only had two equations, then I could not figure out what the three variables are. I wouldn't have enough information. And I'm not going to prove this right now, why that's the case. But the way that linear systems of equations work is that you need the same number of equations in order to figure out that number of variables. So you have to have the same number of equations as you have missing values to figure out what those values are. And since these are the values we want A, we want B, and we want C, these are what we're trying to figure out. These generals are trying to figure out here. We know what they are. They don't. They'll need all three of them to come up with these equations to be able to solve for A, B, and C. So let's see what that looks like. Let's see how we're going to do that. I'm going to use the quick and dirty way, which is kind of mean because it's not the way that you'd be shown for a while yet in school. But I really don't like the way it's typically shown in school. It takes a long time, and and I'm having enough trouble just trying to find a room to write this stuff. I'm going to do it the way that makes the most sense to do it. So, first what I'm going to do, I was going to divide everything by 3 just to make, but then I'd get a fraction over here. So I'm going to leave this as it is. I'm going to create what's called a matrix. It sounds very ominous. And all I'm going to do is to solve for A, B, and C, I'm going to put the current coefficients for my missing values here into the matrix. So I have 1, 1, 1 for A, B, and C. They're all equal to 1. And on the far right-hand side here, I'm going to have a line. This is called an augmented matrix because all it's doing is showing the same information it's the same information, just written in a different way. Coefficients to this one are 9, 3, and 1 are equal to 6. 25, 5, 1, 25, 5, and 1 are equal to 28. 28. All right, and then I'm going to do something called row operations. I may actually, let me see if I can memorize this thing. 1, 1, 1, 0. I think I can do this. 1, 1, 1, 0, 9, 3, 1, 6, 25. Hold on a second. I'm going to write this down somewhere else because I'm going to use a different pad that might be faster and I'll have more room to finish completing this. All right, so let's see. Now let me see if I can get my other pad open. My sketch pad. This is what I used in the other video I think I started for you. Yes, this is what we used, so I'm just going to use this again because right now it makes more sense. Okay, so let's see. Let's see. Yeah, blue's fine. So I wrote it down just to be sure I didn't forget it. I need a little bit more space than that. 1, 1, 1, 0, 9, 3. You're probably thinking these generals would never figure this out, but this is actually, with enough practice, a very simple procedure. And you'll have lots of years of schooling to show different ways of doing it. I just don't like the ways that they show. This is my favorite way, is using a matrix. It's simpler. It takes a little bit of know-how, but once you get it, it's really easy. So here's what I want. What I want is, in order to figure this out, I am going to start with wanting this whole row here to be nothing but 1s. I just want 1s, and it's saying a row, but it's a diagonal. I want that to be 1s. This represents my A, my B, and my C. So if I can figure out if I can get this 1 here and I make these zeros, that means that I have 0 A's, 0 B's, and 1 C is equal to something over here. It'll tell me what C is. Then I can plug that in up here, and I can figure out the rest of it. So I'll show you how this works. So first what I want to do is I want to make this over here zeros. These need to be zeros over here. This is called reduced, no, it's not. This is not, we're not going to full reduce. We're just doing row echelon. I had to think about that for a second. Reduced row echelon is something else. Row echelon form means we're going to make this look a certain way so we can find variables. So, and you'll see when we translate it back into equations. So let me see. To make this 9, what I can do, I'm going to do a little trick here. I'm going to perform what's called a row operation. If I think of this as row 1, row 2, row 3, all right, then what I'm going to do is I'm going to multiply row 1 by -9. I'll show you in a second why. I'm not going to put it in here in place, though. I'm just going to think of each one as being multiplied by -9 and add it to what's in row 2. So everything to row 1, everything's multiplied by -9, and then I'm adding that to row 2, and then I'm going to substitute what's in row 2 with those numbers. So that will make a new matrix down here where I will have done that. In fact, yeah, I'll do that. I'll do it this way. So I have the original, and then I'll just keep playing around with this one here. So the new row 1, 2, and row 3, etc. Okay, so I'll keep row 1 the same because it's perfect as it is. I like it like it is. And let's see, -9 times 1 is -9, plus 9 will give 0. -9 times 1 is -9, plus 3 is -6. -9 times 1 plus 1 is -8. -9 times 0 is just 0, plus 6 is 6. So that'll stay 6. Cool. And then technically row 3 would stay the same. But I'm going to do something now to change row 2 again, and then I'll change row 3 last. Like I said, I want this diagonal to be all 1. So now that I have a 0 there, I'm going to make a 1 out of this one. So the next step I'm going to take, we'll say that was my first step. The next step I'm going to take is I'm going to divide everything in row 2 by -6. So I'll say -1/6 times row 2, which is the same thing as dividing by -6. Excuse me, I'm losing my voice. I'm going to replace everything in row 2 with that number. So what's going to happen? Well, -1/6 times 0 is 0. That stays the same. -1/6 times -6. -6 divided by -6 is going to be 1. That's what I wanted. Perfect. Then -8 divided by -6. Negative makes it positive. So I'll just have 8 over 6. And 8 over 6 can be reduced to 4/3. So let's make that 4/3. It's okay if we have fractions right now. No problem. Then 6 times -1/6. Positive divided by negative will make it negative. And then 6 divided by 6 will make it 1. So now we have 1 for row 2. We're done with row 2. Now I have my diagonal, which is wonderful, except for one problem. These all need to be zeros. I can't finish solving this without zeros. And hopefully you'll see why when we get back to the equations part of this. So I need to work on row 3 now. So what I'll do is I'm going to do something to row 2 and in a similar way add it, and then we'll divide later to get this 0, 0, 1. And then we'll see what that means in a second when we translate it back into those equations we saw. So let's make 25 into a 0. If I excuse me again, if I multiply -25 to, not row 2, excuse me, to row 1, that's what matters, to row 1. If I multiply -25 to row 1 and add that, then something cool will happen. I'll get some zeros. So -25 times row 1 plus row 3. And then we'll substitute row 3 with what we get. So -25 times 1 is -25, plus 25 will give us 0 here. 0. -25 times 1 here, plus 5 will make -20. Cool. -25 times 1 is -25, plus 1 is -24. And -25 times 0 plus 28 will stay 28. Cool. Okay, so now I've got that 0 there. That's awesome. But I need another 0 here. I want 0 all the way up to this kid. And then I need this to be a 1. So to make -20, you can probably guess, I'm going to take another step, multiply positive 20 to, positive 20 to row 2. Now, why to row 2 and not row 1 this time? Well, let's think about it. If I multiply it to row 1 and then I add it to row 3, I'm going to get 20 down here again. It's not going to be 0 anymore. But if I multiply to row 2, I'll get 0 plus 0 is 0. So that's what I want. I want to change row 3, so I have to multiply to row 2 now. So we'll get, and then plus row 3, plus row 3, substitute into row 3. Okay, 0, 0, we saw that. 20 times 1 is 20, plus negative 20 will make row 3 0. Let's see, positive 20 times 4/3, that's annoying. Well, 20 times 4 is going to be 80, and that's not divisible by 3. Oops, I don't want to do that. In other words, let's do the work over here. All right, so 20 times 4 is going to make this equal to 80 over 3, right? But when I add that to negative 24, in other words, now we have to figure out what. This is so frustrating sometimes. This is the worst of it, though. Then we'll be in the clear. 80 over 3 minus 24. All right. Well, to figure this out, let's multiply the top and the bottom by 3. So just like you did in elementary school, we're just trying to subtract fractions here. 3 times that is going to be 672. So 80 minus 72 is 8 over 3. That's not so bad. So 8 over 3. Okay, so 8 over 3 is what we get. Hopefully I did that right. We'll know that if I get the wrong answer at the end of this whole thing, if we get the wrong function, this is where I messed up probably. But hopefully not. And then if I do 20 times negative 1, I'll get negative 20 plus 28 will make it, that's 28 minus 20 is just 8. Fantastic. We have one last step. Oh, this is so exciting. Okay. This is so exciting. We're going to get rid of one of our fractions this way too. So finally, I need this to be 1. I need this so I have my diagonal of 1s and everything to the left are 0s. Okay, so 8/3. So to get that, if I divide everything, or in this case multiply by the reciprocal of the fraction. So instead of 8/3, let me multiply row 3 by 3 over 8. Because if I do 3/8 times 8/3, everything cancels, I just get 1, and that's what I want. And then I'm substituting row 3 for that. So 3/8 times 8/3 is, of course, 1. That's what I want, 1. And then if I do 3/8, this is all done. If I do 3/8 times 8, those cancel out. I'll have 3 over 1, which is 3. So that's awesome. Here is 3. Notice, there's the 3, that's the first part of our code. Already the generals are on the way to getting all of it. So let's translate this back into those equations we had. We had a plus b, I'm looking up here for the original. A plus b plus c, actually I'm not going to write the original, we know what the original equations were, we want the new equations. A plus b plus c equals 0, no problem. 0a, so I won't even write a, plus b, plus 4/3 c equals negative 1. Finally, c by itself, because everything else is 0, is equal to 3. So I've translated this back in. C is equal to 3. I can figure the rest of this out. Because if I know that c is 3, let me plug this into this guy. Then b plus 4/3 times 3 equals negative 1. Those cancel. I'll get 4. Then if I subtract 4 from both sides, I'm going to get b is equal to negative 5. Say what? That is correct. We know this. The generals don't know yet, but the generals already have almost their entire key figured out. They almost have the code. They have c is equal to 3, b is equal to negative 5. Now they just need a. Let's see if it works. So this translates to a. We input plus negative 5 for b plus 3 for c equals 0. That means that negative, this is the same thing as saying a negative 5 plus 3 is negative 2, so a minus 2 is equal to 0. That must mean, if I add 2 to both sides, that a is equal to 2. Hallelujah! We've got it. So the polynomial, the quadratic function they need is 2x squared plus, not plus, because it is negative, we want negative, so minus 5x. That is a minus sign, minus 5x plus 3. And that is it. Now all they really needed were the 3 numbers. So they were done as soon as they figured out what A, B, and C were. They would have their code and they could solve the problem. Fantastic. Fantastic. So, as you can see though, it required having 3 equations to figure out what the 3 variables were, what the 3 coefficients were that we were looking for. So that is one way, and honestly, I know it looked complicated, but the simplest way, I won't say the easiest, but the simplest way to figure this out, we figured out, just to write it again, that well, we don't need to write it again. We figured out what it was up here. I'll just write it as I talk though. So let's apply this now to the second part of the problem, and then we'll be done. We'll be wrapped up with this whole thing. What about the general situation? Ha ha ha, very funny. Generals, get it? General situation with n generals and any m that any m can launch, but no set of m minus 1 can. So I'm not going to talk about this formally, but here's a really quick and easy way to think about this. So think about how many, let's just keep the same number of generals. It shouldn't at this point matter. If we keep the same number of generals, or just whatever the number of generals are, but we want them to have we want 4 of them to have to get together in order to figure out the code, then as you can probably guess, if 3 generals had to come together to get the 3 coefficients for a quadratic function that is of degree 2. That's what quadratic means, degree 2. Right? Then what we would have, if we wanted, say, 4 generals to have to come together, then we would have to have a polynomial or a polynomial function with 4 coefficients. And that would be of degree 3. So we would have something like 2x to the third minus 5x squared plus 3x plus some constant, plus 1 or whatever you want. So for each situation, you just have to be sure that you can, in other words, you can give them 4 points and they could figure out something for something of degree 3, by the way, looks like this. I'll erase this in a second just to prevent confusion. It'll look like that. So instead of a curve that looks like that, like for our situation today, a different situation, if you wanted 4 of them to get together, you would need 3 points in order to create a cubic function, which is of degree 3. You wouldn't want to give them the roots for the same reason. 3 of them could get together and solve it. You would have to choose as long as integers were the most important thing about it. So you'd have to choose 3 points. Only 1 or 2 could be roots at most.